Hello guys, welcome back to my channel Learnopedia Let's Succeed. Today we are going to see the third chapter of geometry, that is circles. Now these are the topics we are going to cover in this video. Now the first topic is basics of circles, next is what is tangent and secant, next is tangent theorem and then its converse, and the last theorem is tangent segment theorem. Now these are the topics we are going to cover in this video. The remaining topics we will cover in the next video. So moving to the first topic, that is the basics of circles. Now in the basics of circles, we will see what is the diameter, chord and radius of the circle, and further topics like intersecting circles, concurrent circles, congruent circles, and the last is the circles passing through 1 point, 2 point or 3 point. So these are the topics, subtopics which we are going to see under this topic, that is basics of circles, right? Now in our previous classes, that is maybe fifth or sixth standards, we have learned what is the radius of a circle, diameter and then chord, right? So the basic things we are going to revise here. In this circle we have OF or as the radius. So OF is the radius of the circle. Now why it is called as the radius? Because it is the line joining to the center of the circle and the point on the circumference of the circle. So this is the radius of the circle. Next is the diameter of the circle. Now diameter, we know that diameter is 2 times the radius of the circle, and it is the line which joins 2 points on the circumference of the circle and is passing through the center of the circle. Okay, so remember this point, that it passes through the center of the circle and join 2 points on the circumference of the circle. So this A and this B is the points, are the points on the circumference of the circle, and this line joins these 2 points which passes through the center of the circle. So this is the diameter of the circle. Next is the chord of the circle. The same definition goes for this, that is line joining the 2 points which lie on the circumference of the circle. That is, in this case, C and D are the points which lie on the circumference of the circle, and this line joins these 2 points. Now remember this thing, that in a chord, it is not necessary that it passes through the center of the circle, but if you see, diameter is the line which joins 2 points on the circumference, so we can call it as the biggest chord of the circle, क्योंकि diameter से ज़्यादा कुछ हो भी नहीं सकता in a circle, right? Length of a diameter is the largest. Now moving to the next topic, that is the congruent circles, concentric circles and intersecting circles. Now congruent means having the same shape as well as the same size. This we have learned in the similarity chapter, right? So in this case, these two circles, that is this one and this one, have the same shape. Circles means having the same shape as well as the same size. इनका जो radius है, that is of same length. So these are the congruent circles. Now next is the concentric circles. In a concentric circle, the center of the circles remain the same, only the radius keeps on going changing. So in this case, this is the chota circle in which it has this center. Suppose this center is O. So this is the radius of the chota circle. Now if you see, from the same point we have taken the another circle, that is this bigger circle with another radius. So what I mean to say is, the center remains the same, only the radius keeps on changing, and we can draw a infinite number of circles using one center as 1 point as the center. Okay, so next is the intersecting circles. In the intersecting circles, we have like 2 circles are there, and these 2 circles, if they intersect, they will meet in 2 points, that is this and this. So it is, see, if we just draw another circle here, it will again meet in 2 points. So whenever 2 circles meet, they will meet in 2 points. remember this thing. Just try on drawing like where a circle meets in 3 points. You will not get it, but if you want, you can just try it. Right? Whenever you draw cases of circles, it will definitely meet at 2 points. Right? So this is what congruent circles, concentric circles, and intersecting circles mean. So now let's see how many circles can pass through 1 point, 2 point, or 3 points. Now first I will tell you, just notice this diagram, observe this diagram, and try to analyze which is the only one point from which all the three circles are passing, right? So according to me, in this diagram there is only one point from which all the circles are passing, that is the point A here, right? Now in this, if you see or if you try to draw the further circles, you can draw infinite number of circles passing through a point, right? See, it's like this. I can draw a circle here from passing through this point. I can draw a circle like this. I can draw a circle like this. Anywhere I can draw. So we can draw infinite number of circles passing through one point, right? Now let's analyze how many circles can pass through 2 points, right? I will just erase this thing and then we will move ahead. Now let's see what are the 2 points from which these two circles, circle with center P and circle with center R, intersect, right? So these are the 2 points, that is the point A and the point this one. Let's name it as C. So these are the 2 points from which the two circles pass. Now let's join this line, that is AC. How many circles can we draw from this thing? If I say we can draw infinite number of circles, is it possible? Just think, give it a think. Yes, it is possible, because see, if I assume this as the say diameter, then I can just draw a circle like this passing through these 2 points, right? I can also assume this line AC as the chord of the circle, right? So this is how I can draw it. This is how I can draw it, right? Also, there is one more method we can analyze how many circles we can draw. That is, if we just, I will just erase it so that I can explain it properly. Right. Now these are the 2 points, that is, this is the C point, right? And this is the line. So these are the 2 points. Now if I take a point here and just join these two points from that, I get a triangle here. Now joining these 3 points, that is A and this triangle ka point and this thing, I get a circle here, right? Now again I take a triangle, a point here, and I draw a triangle, and again I do the same procedure. So in this way I can draw infinite number of triangles and I get infinite number of um, circles. So this is how we can draw circles from 2 points. Now the next thing is a circle passing from 3 points. Now how is it possible to draw a circle passing from 3 points? There are two cases in this, that is collinear points and non-collinear points. So the collinear points are points which lie in the same line. So this is the line and this is these are the 3 points. Suppose I take a point here, these are the 3 points, and from these 3 points we need to pass the circle. Is it possible to pass the circle from all these points? Like, let's try. This I start from here, I just join this point and go ahead. Did I cover all the 3 points? No. Let's try something another thing. Now I try from this point, I just go from here, I just cover this point and again go back to that point. So this time also I covered only 2 points, right? Now this is the case of collinear points, and collinear points I'm not getting all the 3 points in the circle, or all the 3 points do not lie on the circle, right? Now we will try for the 3 points which are non-collinear. Now let's see, non-collinear points are those points which do not lie on the same line, right? So if I take these 3 points here, that is this, and this point, can I pass a circle from these 3 points? I need to do a lot of construction, and after that, doing so much of construction, I will get only one circle passing through these 3 points, like this. Like, I'm not going to draw it, the bisectors and all. I'm just going to connect these 3 points and we will get a circle. So there is a lot of construction we need to do for drawing a circle from the passing, which is passing through these 3 points, right? So this is all we have to cover in this topic, that is how many circles. Now you can just guess how many circles pass through 4 points, 5 points, according to you. This is only till 3 points which I have covered. Now this was the basics of circles, and now we will move to the main topic of the chapter, that is tangent secants. So first we will explain what is tangent secant. So let's move ahead. Now what is a tangent and a secant? A tangent is basically a line which meets the circle at one particular point, and a secant is a line which passes through 2 points which lie on the circumference of the circle. Now we will see with an example what is a tangent and a secant. So in the first figure, we can see that is the figure in which the center of the circle is A. So this is the figure, and in this we have a line L which does not touch the circle at all. So this is just a line, separate line, and this is just a separate circle. Now in the second figure, that is the circle with center B, we have the line touching the circle at one point, that is P. So this is the line which is called as the tangent of the circle. So what is the definition which I told you? That the line which meets the circle at one point. So this is the point where it meets, and it is called as the tangent of the circle. Now the secant. The definition of the secant was it passes through 2 points which lie on the circumference of the circle. So these are the 2 points, that is Q and R are the 2 points which lie on the circumference of the circle, and this is the line which passes through these 2 points. So this is called as the secant. Now you will have a question that is a chord also called as the secant? No, a chord is just a segment and a secant is a line. Like line can be extended, like it has 2 arrows, and the chord has just 2 points like this. It cannot be extended. It has a fixed length. Okay, so it cannot be extended. It does not have an arrow here like this. So this is the difference between a secant and a chord. So this is what a tangent and a secant means. Now moving to the next topic, that is the tangent theorem. Now we have the tangent theorem in front of us. The statement of the theorem is a tangent at any point of a circle is perpendicular to the radius at the point of contact. Now before starting this theorem, I just forgot to mention one thing about the tangents. On a circle there can be many tangents. Like if I take this point, I can draw a tangent here as well. If I take another point here, I can draw a tangent like this way. Each point has its own tangent. Remember this thing. So there can be more than one tangent. It can be 10, as many as points are there on the circle. We can draw that much tangents. Okay. So next is the tangent theorem. Now in the tangent theorem, we have read the statement: a tangent at any point of a circle is perpendicular to the radius at the point of contact. Now what they have said is, if this is the tangent, that is the line L, and OA is the radius of the circle, then this radius is perpendicular to the tangent of the circle. Right? Now the given thing is line L is a tangent to the circle with center O at the point of contact A. Now what is the point of contact? Point of contact is any point where um, the line or circle intersects together. So this is the point of contact for the line and circle in this case. That is the point A. Right? To prove the line L is perpendicular to the radius OA. This is what we have to prove. For proving this thing, we need to do some assumptions and construction. The first thing we have to assume that line L is not perpendicular. Remember this thing, not perpendicular to the segment OA. Now the thing which we have to prove, we have assumed that it is not perpendicular to OA. Okay. And the next thing is we have to construct a line segment OB to the tangent. Perpendicular line segment. Suppose this is the tangent L. We have to draw a segment OB from the center of the circle which is perpendicular to this line L. Right? This is the construction we need to do. Another thing they have said is this B is not the same as A because we have assumed that A is not perpendicular to the line L. So B and A cannot be the same. Another thing they have given is take a point C on line L such that point A, B, C are collinear and BA is equal to BC. So this is the point C, suppose this will be the point A. Now these 3 points are collinear and this segment that is BA and this segment that is BC will be same or equal, right? So this is the construction we need to do and we need to just join these two lines or points, that is OC and OA. This is what we need to do. The neat diagram is on the next slide. Now here the proof starts of this theorem. First we need to prove these two triangles which are formed. We need to prove these two triangles similar, that is OBC and OBA. So these are the two triangles, we need to prove them similar. Now in this, for proving them similar, we know that these two segments, that is BC and BA, are equal from the construction, right? We know this thing. So we can say that segment BC is congruent to segment BA by the construction. Next is angle OBC, that is this angle is congruent to angle OBA. This is also from the construction as we have drawn this OB perpendicular to the line L. So both these angles are 90 degree. Since they are 90 degree, they are congruent to each other. Next is segment OB is congruent to segment OB. Again, because this side is common from both the triangles, so it is congruent to each other. Therefore, triangle OBC is congruent to triangle OBA by SAS test. Now, this test we have learned in the similarity chapter. Since they are congruent to each other, we can say that OC is equal to OA. This side, that is this one, is equal to OA. Right. From the previous diagram, that is this main diagram, we know that OA is the radius of the circle. Since OA is the radius of the circle, we can say that OC is also the radius of the circle and C lies on the circle itself. Now suppose, I will draw a circle here, a small circle. This is O and this is this C, this will be A. So these are the 2 points which will lie on the circle, and since B is the point in between them, we can just draw a line passing through these 2 points and B is lying between them. If you can just see, this line L is passing through the 2 points which lie on the circle, and it becomes a secant and not a tangent, and we need to prove that the tangent is perpendicular, right? And this is not a tangent, it is a secant. So the given statement itself gets changed. So the assumption we did that the OA is not perpendicular to the tangent is wrong. Hence, line L is perpendicular to the radius OA. This is how we prove this theorem. So we will just systematically read it. I have just already explained you what it is. So as I said, OC is equal to OA, but segment OA is a radius, right? We said we look at this. If this is the radius, this will also become the radius, right? They are equal. So C lies on the circle. That means line L intersects the circles in two distinct points. That is that is C and A. So, but line L is a tangent. It is the given statement. We cannot change that statement, right? So we cannot change that statement, but we can change our assumption. That is, line L is perpendicular to line radius OA. So this is what we had to prove, and this is how we proved it. Now this is a simple theorem. You need to just understand it, what we did, and it would not be asked in your exams at all, because at our times it was not asked. And yes, you have to remember this concept throughout your studies because it is required throughout. And uh, also you will require it for solving the sums further in the exercise, right? Now we will see the converse of tangent theorem. Now this is the converse of tangent theorem, and we know that converse means the ulta of something. We proved the tangent theorem, in which we had to prove that the radius is perpendicular to the tangent of the circle at the point of contact, right? Now in this theorem it is given that the radius is perpendicular to the line which is meeting at the point of contact, but it is not given that the line L which is meeting is a tangent. We have to prove that this is a tangent. Okay, so the statement of the theorem is a line perpendicular to a radius at which at its point of contact on the circle is a tangent to the circle, right? So this is what we have to prove. That is we have to prove the line to be a tangent. Okay, so the given thing is M is the center of the circle. This is the center. Mn is the radius of the circle, and line L is perpendicular to the segment Mn at N. This is the perpendicular. Now if you notice here in the given thing, they have not mentioned that line L is a tangent. Okay, so remember this thing. You have to prove that it is a tangent, right? So to prove line L is a tangent to the circle. Now moving further. Now for that we need to take a small point P on the line L, which lie somewhere here. That is, if you can see here, this is the point P, and further we have to join this MP line, and it is a simple proof. Using this triangle we have to prove everything, that is MNP. Now in this triangle it is a right angle triangle, right? And N is the 90-degree angle, right? So this will be our hypotenuse, and if you know, the hypotenuse of a triangle is greater than the other two sides, so we can say that segment MP is greater than segment MN, right? Because it is a hypotenuse. Now since this is the condition for this triangle, and Mn is the radius of the circle, this is the radius, right? And this MP is greater than Mn, which means it is greater than the radius. So the point P lies outside the circle, this point lies outside the circle. From this we prove that point P lies outside the circle. And since it lies outside the circle, and if the line is passing through that point, we cannot say that it is a tangent, right? It should pass through a point which is common for both line as well as the circle. Now you can say that if we take another point here also, suppose this is the point C, then again if we try to prove it that this point lies on the circle, that is the C point lies on the circle, we cannot prove it because again this length will be greater than the radius. So there is only one point which lies on the circle, and that is N. Okay, so definitely this is the radius of the circle, and this is perpendicular to the line given, and none other than N point N is perpendicular. We can see here this is not perpendicular, this is not perpendicular. So hence we say that line L is the tangent to the circle. Now in this slide I have written the explanation for that. That is, take any point P other than N on the line L. This is what we have did. Now draw segment MP which join that line like this way, right? So this was the point P somewhere, and this was the radius. So we just join that thing, and what we got is a right angle triangle, right? So segment MP is the hypotenuse, and segment MP is greater than segment MN. So this is greater than this MN, right? This we prove. And as segment MN is radius, point P can't be on the circle. No other point except point N of line L is on the circle, right? So only point N which lies on the line L as well as the on the line on the circle, and we have saw that point P or point C which does not lie on the circle here, because always if you draw a hypotenuse or something or try to find the length of this lines, you will get it greater than the radius, right? So this won't happen, and we cannot prove that thing. So hence we prove that line L is the tangent to the circle, right? So this was the converse of tangent theorem, and also it is not that important for you. Just remember the concept and try to solve the questions based on this concept, okay? So it won't be asked in your exams like prove this theorem. So don't worry about that. And now we are moving to the last topic of this video. So let's start with the tangent segment theorem now. Uh, First I will read out the statement of the theorem, that is, tangent segments drawn from an external point to a circle are congruent. Now in this theorem we need to prove that if there is a point, that is a point which is common for both the tangents, and from that point two tangents are drawn to a circle. So now in this case this is the tangent, that is dq, and this is the another tangent, that is dp. So these two are the tangents to the circle. If we draw two tangents from a common point, then the length of the segments of the tangents is same. That means this dp and this dq will be same. So this is what we have to prove equal, and it is a chota theorem which is very easy and which is very important from your exam point of view, as it will be asked in your exams. Okay, so try to understand it properly, and yes, we will move ahead. Now the given thing is the center of the circle is A. This we know, right? So this is the center of the circle, and PD and QD are the tangents of the circle. So this I told you right now. And what we have to prove is PD is congruent to QD. So this is what we have to prove. For proving this thing, we need to do a small construction. That is, we have to just draw radius AP and AQ. So these two are the radius of the circles. Now if you remember, we just proved something just now, that is, when we draw radius to the tangent, radius to the point of contact, joining the point of contact, it is perpendicular to the tangent, right? We proved it just now. So this is perpendicular to the tangent. Now moving ahead to the proof. Now since we have connected these 2 points, that is AP and AQ, and drawn the radius, we get two triangles, right angle triangles, which are DQA and DPA. So these are the two triangles which we get. I will just mark here, that is PAD and QAD. Now in this, segment PA is congruent to segment QA. Now why PA is congruent to segment QA? Because this segment and this segment is the radius of the same circle. Hence they are congruent to each other, right? Next is segment AD is congruent to segment AD. This is because it is the common segment between both of the triangles, right? So this is the second thing. And the last thing is, this triangle is 90 degree as well as this triangle is 90 degrees. So they are congruent to each other and both are 90 degree by tangent theorem, right? This is what we have proved. And using this 3, that is side and angle and side, again we get the two triangles congruent to each other, that is by SAS test, right? Now since these both triangles are congruent to each other, we can say that segment DP is congruent to segment DQ by congruent congruent sides of congruent triangles, right? But this is the full form, congruent sides of congruent triangles, CSCT, right? So this is what we had to prove, and we have proved it. Now this theorem, as I said, it is important. Just try to understand it. It is easy, like 3-4 steps and you will get the thing you need to prove, right? So just try to understand it properly. You need to use them in your sums as well. So understand it, okay? Now we will just revise what we have learned in this video and then end up with this video, right? So yeah, let's revise what we have learned. So the first thing which we learned is the basics of circles, in which we revised everything which was taught in our previous classes, right? In which we learned diameter, radius, chord, then we learned what are congruent circles, what are concurrent circles, and then the intersecting circles. What are concurrent circles? Concurrent circles are the circles which have a common center, only the radius keeps on changing, right? So these are concurrent circles, like this. This is one circle. This is the center of the circle. This is another circle whose radius is changing with the same center. Okay, so just don't mind my drawing. It is I'm not able to draw here. So you can just imagine that thing, right? Now intersecting circles, we know what it is. Intersecting circles are these circles, right? So they intersect in 1 point, maybe they intersect in 2 points. Generally they intersect in 2 points. Next is we learned how many circles can pass through 1 point, 2 point or 3 points, right? So from 1 point there can be infinite number of circles which can pass. From 2 points also we have seen that there are infinite numbers of circles which can pass, and from 3 points we have seen two cases, that is collinear and non-collinear. Now from collinear, that is the points which lie on the same line, there are no chances of passing the circle from all the 3 points, right? So there is no circle which passes through 3 collinear points. And from non-collinear points, as I told, we need to do construction, that we have to draw bisectors and all, and doing that we get only one circle which passes through all the 3 points, right? So this is what we have discussed in the basics of circles. Next we learned the tangent and secant. Now what is a tangent? A tangent is the line which passes through the only one point which lies on the circle. So this is the tangent for this circle, right? So this will be the tangent for this circle. The secant is the line which passes through 2 points on the circle. So if here is one of the point and here is the other point, then the secant will pass like this, somewhat like this. So this is the secant of the circle. right? So this is what we learned in the tangent and secant. Now there can be number of tangents for one circle. As I told you, each point has different tangent. Each point has its own tangent. Like this, it can be drawn like this, it can be drawn like this. So every time a new point, a new tangent will be there, right? Now next is the tangent theorem. In the tangent theorem, we saw that if we have a circle and the tangent passes through the one point of the circle, this is the center of the circle, and radius is drawn to the point of contact, then this radius and the tangent is perpendicular to each other. This is what we have learned in the tangent theorem, right? And in the converse of tangent theorem, we had been given a line which was not a tangent, and we had to prove that it was a tangent, right? So they had given us that the radius is perpendicular to this line and prove that this line is the tangent to the circle. So we proved that in the converse of tangent. Now these two theorems are not that important for your exams. So just remember this concept that this is perpendicular and this everything, and you will be able to solve the questions easily, right? Now this theorem, that is the tangent last theorem, tangent segment theorem. Now this theorem is based on the tangent theorem. So for this, proving this theorem, somewhat you need a tangent theorem there, and you have to prove that. In the tangent theorem, we proved that if there is a circle and there is an external point, now from that external point we have two tangents drawn, then the length of these two tangents is equal. We proved that in this theorem. Now this theorem is very important from the exam point of view. Try to derive it on yourselves and get it well understand by yourselves, so it would be easy for you to write it in your exams and solve the question based on it. So now this is all for today, and thank you for watching my video, guys. I hope you are able to understand everything whatever I am teaching you, and do share this video or the previous videos to all your friends who are currently in 10th standards. I hope it would be also helpful for them. So please, and also don't forget to like, share and subscribe my channel. So thank you for watching once again.